Okay, so you wanted some help getting started on this. From what I could tell, it sounded as though you had found the ordered pairs okay. So you take some thetas, you then double theta. I just kind of like to stretch out the equation following order of operations. Then I do 2 times, then I do sine of 2 theta, then I do 2 times that column. And this is my R right here, this column. All right, so then I'll have my ordered pairs, and you write them with R first and then your theta. So the ones that are currently in my table are 0, and then I just kind of use the 30-degree angles. Okay, so that's what I gave you in the table. All right, so one of the issues on this one is that as you, let me not talk while I'm finishing this part, 2 pi over 3, and then 5 pi over 6, and then we're back over there to pi, okay? And then it kept going all the way to 2 pi. So it sounded like you knew how to get those. So we doubled theta on all of these. So let me just go through and double theta. Doubled. That would be 4 pi over 3. Doubling that one would give me 5 pi over 3. And then doubling that would give me 2 pi. And you kind of just went through all the way to the end of the table. Then when you do sine of 0, you're 0. Sine of pi over 3 is square root of 3 over 2. Same for the sine of 2 pi over 3. Sine of pi was back to 0. 4 pi over 3 was negative. The sine of that was negative. Sine of 5 pi over 3, same thing. And the sine of 2 pi was 0. So when you doubled all of those, took 2 times that column, then you did wind up, like you said, with just square root of 3's and 0's and negative square root of 3's. Okay, so that's what I had, just a sampling of what's in the table. So I had to plot 0, 0, square root of 3 with the pi over 6, square root of 3 with the pi over 3. Make sure you're doing it with the original angles. 0 with the original pi over 2. Okay, negative square root of 3 on each of these. So that's at 2 pi over 3 and at 5 pi over 6. And then here we got an R of 0 when we were at pi. And then you would have, in the table, had a whole lot more than that. Okay, so here's the issue. When you plot just that information, I'm going to squeeze this just a little bit. When you take that information and you try to put it on a polar graph, all right, so your 30, 60, 90s, let me draw those in, okay. All right, there's your 30, 60, 90s, okay. And so when you start trying to do those on a polar graph, you're going to have these rings, okay, coming out from there. You're going to want to know the decimal for the square root of 3. So square root of 3 is about 1.73. Okay. All right, so I'm going to plot the points in blue, maybe red, so they really show up. So at 0, you're at 0. When you're at pi over 6, you're at 1.73. So you'll be out like to here. Okay, that's a little off. That this one right here is not a very well drawn one. I think I'll just leave it though. Okay, I'll just leave it where it is, but it's supposed to go through the origin and all. Okay, all right. Then when you're at pi over 3, which is up here, you're also out at 1.73. Okay, so you're going to be, I need to redraw that. Let me just pull up a piece of graph paper so it really looks better. So let me go back and just pull up an actual graph paper out of my documents. So let me see, polar graph paper is what I'm looking for. All right, let me see if I can just grab a piece off the back of that packet. Okay, so I'm just going to snip one of these that's better drawn than my hand-drawn one. Then I'm going to snip this so they're together. Okay, so let me take a snip of that, and then they should be right, the table should be right next to the graph paper I'm trying to use. All right, so here's the graph paper. And then the one that I included in the document sharing kind of highlighted the 30, 60, 90. So this would be the 30. And this would be the 60. And so all those little individual things, those are 15-degree increments. Okay. All right, and you would do that all the way around, but I just wanted you to see that. So that's the pi over 6. That's the pi over 3. Of course, that's pi over 2. This is 0 or 2 pi. Okay, and then you keep going around, but just make sure you're not thinking it's here and here. That would be your 2 pi over 3. And this would be your 5 pi over 6, and so on. Okay, and of course, this is pi. All right, so when you're plotting the point 0, 0, let me do this one in blue. Okay. All right, so I'm right there at the origin. That's this one. All right, then when I'm plotting the point square root of 3 pi over 6, at pi over 6, I have to come back 3/4 of the way to 2. Okay. 1 point, even more, a little further than that. It's like even more than 3/4 of the way. It's 1.73, right? So it's close to 2. Then when I'm at pi over 3, it's the same thing. So here's pi over 3. I have to go out till I'm nearly to 2, 1.73. All right, so what I commented on is that you actually would benefit by having some extra data. So it'd be nice to know, what about right here at pi over 4? So I suggested that you come over to this one and you find the pi over 4, which is the 45 degrees. When you double that, you're going to get pi over 2. When you do sine of pi over 2, you're going to get 1. And when you do 2 times 1, you're going to get 2. So that gives you an added ordered pair you can plot. 2 pi over 2. So you're going to come up here to pi over 2, and you're going to go, where am I now? To pi over 4. So when I'm at, that's not pi over 2 though, it's pi over 4. When I'm at pi over 4, which is here, I'm going to be out at 2, which puts me on the second ring out. All right, now this is one of the rose curves. So this is actually going to be one of the petals right there that you're going to see. One of the 4 petals. Okay. And so that got you kind of through to here, to this section right here. All right. All right, so now at pi over 2, we're at 0 again. At 2 pi over 3, I'm at -1. This is -1.73. So when I get to 2 pi over 3, because the r is negative, I back up And remember that you got to follow the location where you're at. Okay, so 2 pi over 3, you have to back up 1.73. So you have to go past 1 and then 3/4 of the way to 2 when you're on that one. That's this guy. And then 5 pi over 6 is the same way. So 5 pi over 6, I go not on the 5 pi over 6 terminal side, but I go backwards. Same deal. Okay. And then again, it would help to have that in-between information on this. So that's what might make that one a little harder to do. So in between those two would be 3 pi over 4. When you double that, you'll get 3 pi over 2. The sign of 3 pi over 2 is -1. And when you do 2 times that, you get -2. So you'll have an additional data point that you can graph, which will be -2 when you're at 3 pi over 4. So here's your 3 pi over 4. Okay, this is the 3 pi over 4 line right here. So instead of being on that terminal side, because of the R value being negative, I'm going to back up 2 units and be right here. So there gives you a second pedal. Okay, and then you should be able to finish it from there. So in your existing table, just add to it what you get at 5 pi over 4, find that ordered pair, and also this one, what happens when you're at 7 pi over 4. Add that into your chart. You should get 2's and -2's, and then see if you can't get all that plotted. And you should have 4 petals. Okay. All right, so I'm going to stop sharing that. So I usually just start with my 30, 60, 90s. And then if I need to, I can always just plot some additional points. So a good one to do if you need additional points is that in between. Okay, so I'm going to stop sharing this.